I figured you'd have some questions about pulleys, so I set up a model over here. Let's try it out. I have 4 kilograms, or about 9 pounds, attached to this pulley system. Go ahead and pull on the string.
That's really easy.
Why don't you lift the weight, which we call the load, 1 meter. We'll call this the load distance.
Wait a minute, Anthony. Where did all this string come from?
I don't know. What's wrong?
Nothing's wrong. Let me explain. Simple machines allow you to multiply your force. In this case, you can lift an object 8 times as heavy as your force.
Right. We learned from the Sci-Files Kids Club that you count the number of strings supporting the load. I count 8 strings, and that's why we can multiply our force 8 times.
Very good, but there is a trade-off.
What do you mean?
Remember that work is equal to force times distance.
Okay.
With simple machines like pulleys, you can multiply your force, but not the work. So in this case, you've multiplied your force 8 times. But how much string did you have to pull in? We'll call this your distance.
8 meters. That means our distance is 8 times the load distance.
Does it always work that way?
Yes, it does. If you multiply your force, the trade-off is that your distance will always be greater than the load distance. Take a lever, for example. Why don't I stand over here and have you try to lift me up by pushing over there. Try it with just one hand.
Okay. Can't believe I just did that. That was easy.
Well, if your force is 5 times further from the fulcrum or rotational point than the load, you will multiply your force by 5 times. But your distance, how far you push down, will also be 5 times greater than the load distance, how far I move up.
This is really cool.
So if simple machines don't allow us to do less work or need less energy, why do we use them?
I guess it's because they make the work easier.
Excellent.
We still need to make our work easier. Right now, we've multiplied our force 3 times by using 3 pulleys. But that isn't enough to easily lift the load of 120 pounds.
But if we add more pulleys to multiply the force even more, that means that we have to pull in a lot more rope.
Wow, maybe we need to use a different kind of simple machine.
Well, don't scrap your pulley idea. You might want to consider combining other simple machines with your pulley system.
You mean like use a lever with our pulley system?
Well, that's a possibility. Another one is a wheel and axle. Take my bike, for example. This could also be called a crank and axle. This wheel with the chain attached is the axle. It's attached to this crank with the pedal. To find out how this machine multiplies the force, all we have to do is divide the radius of the crank by the radius of the axle. RJ, would you make the measurements, please?
The crank is 16 centimeters, and the axle is 8 centimeters. So that means the machine multiplies the force by 2.
That's great.